So in this video, I'm doing find minimum in rotated sorted array. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, this array might become this array if it was rotated 4 times. Okay, given the sorted array nums of unique elements, return the minimum element of the array. Okay. Okay, so we have an ascending array, which is rotated. So the start of the array is not necessarily the minimum, but the array itself is rotated. So every element that comes before another element should be bigger, except for the first element, because when the array is done and it goes back to the first element, it's going to obviously be smaller than the element before it. So in this case, 4, 5, 6, 7, and then the array is done, and then it restarts at 0, 1, 2. So 0 is smaller than 7. So what I can do is I can iterate through the array, then for each element, if the element in front of it is smaller, then the element in front of it is the element I return. That's pretty straightforward, but I want to think about if there's any other ways I can do this. Let me take a look at the hints. So in terms of this, I think the best algorithm would be binary search, repeatedly dividing the search space in half. All the elements to the left of the inflection point is greater than the first element of the array. That's true. All the elements to the right of the inflection point are smaller than the first element. This would be the inflection point. This would be the inflection point. All the elements to the left are greater than the first element. All the elements to the right are smaller. Than the first element. Okay, so I think for now I'm just gonna go with my original idea. I'll see how that works, and then maybe I will optimize this solution down the line, but I just want to code out my original solution, which involves finding the inflection point pretty much, and then just returning the minimum. So, okay, so we can do this in a for loop for I equals 0, I is smaller than nums.length minus 2, I plus plus, it's minus 2 because for each element we need to look at the next element, and so we don't want to look at the last element because there will be no next. So, okay, so if nums at I is greater than nums at I plus 1, return nums at I plus 1. So if we ever find the case where previous element is greater than the next element, meaning it's reset, then we return this one. And then if we don't ever reach this case, that means it would be 0, 1, 2, 3, 4, 5, 6, 7, or something like that. But we would never have a case where this first element is greater than the second element, which means that it hasn't been rotated at all, although they do say it's been rotated between 1 and times. But just in case, we can do return nums at 0. Okay, let's give this a run. Nums at I is greater than nums at 1, I plus 1, return nums at I plus 1. Why would it not work for this case? Nums at I, 2, is greater than nums at I plus 1, so it should be returning, so int I equals 0, I is smaller than 2, minus 2, so I is smaller than 0. Okay, so it's just not even looking at this. So I think it's just this maybe. Okay, and there we go.